Looks like we're recording. Let's do the hide. Okay, we looked at our last program where we basically got the command line and then we printed it out. And then we had a string buffer where we entered a string and printed that out. But what can we do with our command line? That's the question. We need to type stuff in. So we've changed our buffer to 20. We've got a string called help so that we can print, if we type at the command line help, we want to print out like a little help message, which we can use to write various programs. And also calc, we can actually get it to execute the calculator or notepad. So you've got some extra functionality in your program. So let's look at the code. You've got push your buffer to the stack. First argument, get the command line. So ain't that brilliant? You can't get a command line any quicker than that in 3 instructions. And they say that, it's difficult. You've got your buffer, print it out, push your first string onto the stack, which of course is help. So first we look for the help menu, and then we push the buffer to the stack, and then we call string compare. So we're comparing string 1 help with our buffer, what we've typed in on the command line. We compare it with to see if it's 0. If it's jump if equals same, if it's the same. So if it is help, then we jump to here, same, where we put the same message and we print that out. Jump not equal to diff, it's a different message. So we jump down here and we print out, it's a different message. And obviously we jump to past this difference code and on to the rest of the program. So if it's a different message, it means it's not help. So what we need to do is push again string 2 to see if it's calc. Push the buffer, string compare. If it's the same, then it is calc. We want to execute the calculator program. So we jump past the jump not equals instruction, which jumps to the hello set, and the other part of the program that we did in part 1. Otherwise, what I want to do is push a flag, Windows flag. So we're actually mixing console, almost like DOS, and now Windows. We're going to push show normal flag to the stack. We're going to push the offset to the execution path, which is up here. It's the execution path we want to execute is C:// Windows /System32 /calc.exe, the calculator. And you can also do it with Notepad or any other program that you want to be able to thingy. And then we call Windows execute to execute it, and then we move on to the rest of the program as before. So we saved it. Project console build all, work to treat, get the directory. So test help on the command line, and it says help, this is your help message, my program name, input a string here, my string was here, okay. And then it goes, your string that you entered was, my string was here, okay. So now we test the calculator bit, test calc. So we're putting calculator on as the command line argument. So we open that up, and it's opened up our calculator, which is nice. So then what we do is focus back on the into the input into our window and put my fav string, and it says your string that you entered was my fav string. So we managed to get it to use the command line to execute Windows programs or a help file, such as calc, notepad. That's the way to do it. Adds a little bit of functionality, you see. And also what we did, we added instead of doing the spaces, we decided to add the 13 and 10. 13 is carriage return, and 10 is line feed. So we've added them and the 0 terminated strings. So we've added these 13s and 10s to the end of our strings so that it drops it down to the next line. Simples. And then what we're going to do, now that we've got that functionality, we can do quite a lot with that functionality, but what we want to do now is move on to a game in the next episode. So we're going to have a look at a game, creating political and military simulation games for your micro, which is an old book by Mike Rose. Yeah, and he's got a nice little game in here. And we now have the ability to be able to basically have a go at creating this game. Because let's face it, if we can find it. If we can find it. So after all that blather of going on about how the games are, very simple, you see. This will be the thingy. What we do is we basically, the game is rem. No, that's not it. But basically the game, and they're actually all the same actually, these. Basically we initialize the game, and to do that we need to look at arrays. So I found a nice little routine for arrays here. We need a 2-dimensional array procedure. So we can create one by using these local variables, dword, harray, item, string, 16-byte string. We string allocate a 12 by 12 array, and then we'll get the pointer to the array in our array handle. Then we can invoke set item, which is another procedure, and get item, which is another procedure. So get item here will get the item in from AEX into our local variable item, and that's how we're going to basically use something very similar to this in our game. And you see the game get item here is X position, Y position, dimensionality, which is in this case it's 12, and then we need a pointer to our array in memory. So we have another local variable, position 1. So what we do is we multiply our X position by our dimensionality. So if it's 12 by 12, yeah, and then what we do is, so if it's 1, position 1, it'll be 1 times 12. It's 12 plus your Y position, and then you get that back into the position you want is moved into pos 1. Then you basically get your pointer to your array in memory, add your position 1 that you've already pre-calculated in this bit of code, and then you get the item in the array into AEX and return that. So that's what we're going to have to do for our game. because there's going to be it's based on an array kind of model. Then you've got your introduction where you basically typing, printing strings to the screen. Then you're going to display the board. Then you're going to get inputs from the user on what you want to do in the battle. And then you're going to have an enemy orders where the computer will decide, which means we're going to need a random number generator. So we can find a random number generator bit of code dead easily. So that shouldn't be a problem. Then we're going to have to check for collisions in the map. And then we're going to have a look at fighting between the ships or whatever it is. I think Drake's Return is ships. And then we've got damage reports on what happened during the fighting. Then we've got sinkings, any ships that have sank, and damage reports on how much damage a ship has taken, your fleet has taken, sinkings, how many ships have sank, and whether or not and the win loss is whether or not your fleet has been totally destroyed by your enemy, and then go sub. So then you've got the loop, go back to 70 for the next round of the game where you're clearing the screen, which we can easily clear the screen. We've got a command for that. So it should be fairly simple and straightforward to create a game. And then we can move on to other more Windows-based games and Windows-based programming. So it should be good. So next time we'll have a look at writing our first game. Pretty easy. Well, it won't be easy. There'll be a few challenges, but I think we've got all the things. We need arrays. We need a random number generator and a bit of if-then logic. And that's it. No worries. Job's a good one. Should be good.